Okay, so when we have four reservations and when we calculate the probability of two cancellations, our question was why we have six here. Is there any pattern in here? And the answer is yes, there is a pattern, but the pattern is not easy to understand. So I'm going to give you the theory behind it. And by the way, uh, so I love teaching, and I am kind of proud of myself, and try to do my best to give you the intuition of the. I have you try to explain everything, but the only exception is this one, the combination rule. Really hard to explain the intuition why it is going like that. Actually, I think I could, but it would take like a week. So I will give up. I gave up explaining why we get this formula, and maybe this is the only formula that I don't explain the derivation. Just I'll ask you to memorize it. Well, anyhow, you don't need to memorize it. So I just explain as it is. I just show you the formula as it is without much intuition or explanation. I apologize for that, but I think this is what you like. Explanation would cost take a lot of time, so you may not want to see that. Anyhow, I'll define a new mathematical definition operation. Factorial, the exclamation mark in mathematics is called factorial, and n exclamation mark and factorial is the result of multiplying the numbers from 1 to n. So multiply all the consecutive numbers 1 times, 2 times, 3 times, n, right? So we define that result as n factorial. And then what we actually want is the number of possible combinations when you choose y out of n. So there are n reservations, and you know y number of them are cancelled. Now, how many combinations is possible? That's denoted as n choose y. So the notation can be different depending on the textbooks, and but I found that this is the official notation according to the American Mathematics Association, right? So when I was in high school, I used a different notation, but anyhow, this is what we are going to use and choose y. This combination rule, this rule is written this way: n factorial divided by y factorial n minus y factorial. That's the formula. That's the formula, right? It's very strange. And another way to memorize this is we are going to multiply consecutive numbers, y consecutive numbers, in the numerator and in the denominator. But numerator, we multiply from n, n minus 1, n minus 2, and count how many numbers are multiplied. There are y number of numbers multiplied in the numerator, starting from n. And in the denominator, also y number of numbers are multiplied, starting from y down to 1. You see, right? So either way, anyhow, this is the formula. And one special case is when you choose nothing or you choose everything. This is obvious. When you choose everything, there is only one case. Just choose everything. And when you choose nothing, that's also only one case, doing nothing. So this is one, and all the other cases can be calculated this way. So then let's think about this example. Like if in playing cards example, so we know from a deck there are 52 cards. And when you choose 5 random cards, how many combinations possible? That means out of 52 cards, you randomly choose 5. Then numerator multiplies 5 numbers. 52, 51, 50, 49, 48. And denominator also multiplies 5 numbers. 5, 4, 3, 2, 1. And calculate that. Of course, you should use a calculator. Another example. Suppose that you can choose 2 pizza toppings from 10 possible toppings. Then how many combinations possible? 10 choose 2. So multiply 10, 9. 2 numbers, numerator, denominator 2 numbers. Starting from 10 and starting from 2. Right? So this is how we apply the combination rule from mathematics. And then you may apply the same idea, same formula to our case. So now think about 5 reservations. Out of 5 reservations, we are interested in 3 cancellations case. How many combinations possible? 3 cancellations out of 5. Okay, apply this rule, try by yourself. And the answer is like this. So you multiply 5, 4, 3 in the numerator, and 3 to 1 in the denominator. 3 is cancelled out, and then the answer is 10. Just to verify if this is correct, of course it should be correct, but just to see that, I list all the possible combinations, right? There are 5 reservations, A, B, C, D, E, and like write 3 ones and 2 zeros. And how many combinations possible? Like that. These are all the possible combinations you can make up, right? So with this generalization, you can calculate the number of possible cases no matter what n is and y is, like no matter what n and y are. So in the end, we have a general formula for the binomial distribution probability. So if a random variable y follows a binomial distribution with parameter np, then the probability that the number of success equals to y is given by n choose y, the number of outcomes in the event, right, times the probability of a single outcome, success y times, failure n minus y times. This is the general formula for the binomial distribution, right? Of course, this combination rule, n choose y, is actually more complicated formula, but let me just simplify as it is. Then let's go back to the earlier question I gave you. At the so at the time, we considered 10 reservations. There are 10 reservations and everything else is the same. And we would like to calculate the probability that exactly 2 reservations are cancelled. Then what is the probability? And we know the answer. I told you the answer is E, 19.37%. How could we get it? This way. So the parameter is 10 and 0.1, and just apply that. So first part, the number of possible outcomes, 10 choose 2. 10 choose 2, becomes this. And the second part, probability of a single outcome, success happens twice, failure happens 8 times. So this part, is easier. So it becomes this. And, in the end, if you calculate, there are 45 possible combinations. So it's hard to list all the cases. So out of 10 reservations, if you choose 2 of them, there are 45 cases. So the answer is 19.371%. By the way, as you can see, if you choose 2 to 3, so like if you're interested in probability that the number of cancellations is 3 or 4 or 5, then just by changing this number, this number, this number, you can calculate the probability. So what you can see here is what we need is only these two parameters. So if you have these two parameters, by changing the number you put in here, you can get the probability for 11 different possible outcomes. So this is a powerful result. The complicated binomial distribution is simplified a lot. And last remarks. So when you think about binomial distribution, it's a common example in our life. Two common mistakes are made. One is when I say probability that there are two cancellations, often people ignore the failures. It's not explicitly stated. So when I say two reservations are canceled, then you also have to think about the other reservations are not canceled. So this part is often ignored. So that's a mistake. And another problem is not counting the combinations. So two reservations are canceled. People think it's just one outcome, but actually not. I showed you there are 45 possible outcomes. So we have to think about there are different possibilities. So counting all the possibilities is also important in calculating the binomial distribution. So this is how we generalize, how we obtain the general probability formula for the binomial distribution. Here it is, right? So n plus 1 possible outcomes, probabilities for n plus 1 different values can be summarized into this. So we don't lose any information as long as the assumptions are correct. So we just simply make the full information into two numbers. That's all. So there is no loss of information. It is not a summary. It's just equivalent information, right? And finally, this is the shape of the distribution. So all of these shapes are included in the binomial distribution family. And depending on the probability of success, if the probability of success is 10% small, then most probability is placed on the lower side, near 0. And as the probability increases, the probability moves to the larger side. So when 50%, it's symmetric. But other than 50%, the distribution is not symmetric. So the idea, the shape is pretty natural. You know what's going on. By the way, it does not show clearly because there is, because the probability is too small. But actually, there is a small probability everywhere between 0 and 20. So here, for example, probability at 20 is really, really small, so you cannot see that. But there is non-zero, small probability there, like that. Here, 0 has some probability, but it's too small. So all of these three distributions have probability all over between 0 and 20. Now, if you fix the probability at 50% and change the number of trials, then what happens is the range increases. It's always symmetric, but but when n equals to 5, it's concentrated between 0 and 5. When it becomes 10, between 0 and 10. So, and when n becomes 20, it becomes more spread out. So it's more concentrated toward more spread out. The shape is always symmetric, but it becomes more flat, which is also intuitive, right? Okay, so it took quite a bit of time to derive the probability distribution for the binomial distribution. So I hope you see the main idea. And in the next video, I will study more properties of the binomial distribution. So see you in the next video.